Have you ever looked inside one of your gadgets and seen those bulky, kind of weirdly shaped parts sitting next to all the tiny little chips? Well, for decades, putting those components in was a slow manual nightmare for manufacturers. Today, we're diving deep into the S7900, a machine that uses AI vision to solve that exact problem, assembling the, let's call it the awkward squad of electronics with absolutely superhuman precision.
So here's the game plan. First, we're going to set the scene in the world of electronics assembly. Then, we'll look at the problem that made a machine like this so necessary in the first place. From there, we'll pop the hood on the S7900, check out its hardware and software, see the huge impact it's having, and finally, get a little glimpse into what it takes to keep this incredible machine running.
All right, let's jump in. Every complex gadget you own is like a giant, intricate puzzle. And for a long time, one type of puzzle piece was a massive headache. The solution? A new kind of hero on the assembly line. And here it is, the S7900. Now, its job isn't putting in those tiny uniform chips. No, it's a specialist. It's built for what the industry calls odd form components. You know, the bulky connectors, the chunky relays, all the awkward parts that used to just grind assembly lines to a halt. The S7900 was designed from the ground up to automate this huge manufacturing bottleneck.
So, why build such a specialized machine? I mean, really, why go to all this trouble? To get it, we really need to step back and see just how much of a challenge it was to insert these components by hand.
So before automation, this was the reality. You had people carefully placing each and every one of these components by hand, one by one. It was a process that wasn't just slow and expensive, but it was also a recipe for tiny, costly mistakes that could compromise an entire device.
And when you put the two methods side by side, wow, the contrast is just stark. On the left, you've got the human element, with all its limitations in speed and consistency. But on the right, you have the promise of automation. Relentless speed, unwavering accuracy, and a kind of quality control that completely changes the economics of manufacturing. And if you need one number to really put it all in perspective, here it is. A single S7900 machine can do the work of more than 10 manual laborers. That's not just a small efficiency gain. It's a fundamental shift in how a whole production line can operate. So, how does this machine actually pull it off? Okay, let's get into the mechanics of it. We're going to look at both its incredibly powerful hardware, the brawn, and the brilliant software that acts as its brains. The brawn all starts with a rock-solid foundation. Its body is what's called integrally cast, which just means it's made from one single solid piece of metal for maximum stability. And you can see it's built with the best-in-class components out there, from Japanese servo motors and guides to German and Taiwanese parts. This thing is an instrument, and it's engineered for absolute precision, day in and day out. Now this is where its flexibility really shines. See, a machine is only useful if it can handle the parts you actually give it, right? Well, the S7900 can be fitted with all these different types of feeders. So whether the components arrive on a tape, in trays, in tubes, or even just jumbled up in a bowl, it has a system to pick them up. That kind of versatility is absolutely essential in modern electronics. And now for the brains. Honestly, this is where the real magic happens. The S7900 isn't just some dumb robot following a pre-programmed path. It has an advanced AI vision system. Using high-def cameras, it's constantly looking, comparing the components' pins with the holes on the board, and making these tiny little corrections on the fly to ensure a perfect placement every single time.
You know, you'd think a machine this complex would be a total beast to operate, but the interface is surprisingly simple. It just runs on a familiar Windows platform, giving operators a clear touchscreen to control production and monitor all the crucial data, all without a super steep learning curve.
And this quote from the source material really gets to the heart of why this all matters in a real factory setting, greatly shortening the programming and line changing time. In manufacturing, downtime is the enemy of profit. So a smart, easy-to-program system means less time setting up and more time actually building products. So let's put it all together. First, the machine learns the board by scanning some reference points. Then, its cameras identify the component it needs to pick up. As it moves to place it, that AI vision system makes those real-time corrections. And finally, boom! It executes a perfect insertion in as little as half a second. It's like a symphony of mechanics and intelligence. So what's the bottom line here? What does all this technology actually mean for the world of manufacturing?
Well, its impact can pretty much be summed up in 3 simple words: faster, cheaper, and better.
Let's look at the numbers because they are staggering. The speed, as fast as half a second per part. The accuracy is almost microscopic. We're talking within 15 thousandths of a millimeter. And the reliability is baked right in, with systems that can even detect if it missed a component and automatically try again.
And don't think for a second that this is just for some niche product. This technology is a total game changer, and it's everywhere. It's building the electronics inside our cars, our home appliances, the power grid that lights up our cities, and yup, the very gadgets in our pockets.
Okay, for our final section, we're going to go behind the scenes. Because a machine this precise and this powerful doesn't just run forever on its own. So what exactly does it take to maintain it?
Keeping the S7900 in peak condition requires a pretty strict maintenance schedule. You've got simple daily checks like air pressure and clearing out any discarded materials. Every week, key parts like the conveyor belt get inspected. And then monthly, it gets more intensive care, like a thorough cleaning and re-oiling of those critical guide rails.
And these maintenance actions really fall into 2 main categories. On one side, you've got cleaning, just keeping dust and debris away from all the sensitive sensors and moving parts. And on the other, you have lubrication, applying very specific types of grease and oil to make sure all those mechanical components move smoothly and without wearing down. It's this meticulous care that guarantees the machine's long-term accuracy and reliability.
So at the end of the day, the S7900 isn't just a faster robot. It's a complete system that breaks the chains of old manufacturing limits. It solves a critical bottleneck, and it unlocks a level of speed and precision that fundamentally changes how our electronics are actually made. And that leaves us with a pretty fascinating question to think about, doesn't it? We've seen how this level of automation can completely transform a factory floor. So as these systems get even more intelligent, even more adaptable, what other complex, manual tasks in our world are on the verge of being totally revolutionized?